Hi, everyone. Thank you for joining us for today's webinar, Meeting CI/CD Requirements, Key Factors in Test Automation to Consider, with Angie Jones and Jessica Deen. I'm sure you're familiar with our expert speakers, so I'll keep this intro brief. As Senior Developer Advocate at Applitools, Angie Jones specializes in test automation strategies and techniques. A pillar of the global test automation community, Angie is a world-renowned speaker and thought leader, and you can often find her presenting and teaching at international software conferences. She's also the driving force and director of Test Automation University, a free online educational platform providing test automation courses by leading instructors. Jessica Deen is a senior cloud advocate for Microsoft, focusing on Azure containers, OSS, and of course, DevOps. Prior to joining Microsoft, Jessica spent over a decade as an IT consultant and systems administrator for corporate and enterprise environments in the San Francisco Bay Area. Jessica holds 2 Microsoft certifications, 3 CompTIA certifications, 4 Apple certifications, and is a former 4-year Microsoft Most Valuable Professional for Windows and Devices for IT. So without any further ado, Angie and Jessica, the stage is yours.
Hello, everyone. This is Angie. Jessica, you want to say hi?
Hello, everyone. This is Jessica.
Great. Thank you all so much for joining us today. This should be a really fun session. So Jessica and we're going to hack out some web UI tests, and then we're going to add them to a couple of different CI pipelines. So the plan for today is to discuss the main factors that should be considered when we're developing these automated UI tests for continuous integration, continuous deployment, also known as CI/CD. Next, I'm going to write a couple of UI tests for a chat web application. And then Jessica is going to take these UI tests, add them to existing CI pipelines, including Azure, GitHub Actions, and CodeFresh, which is container-based. And I'm going to go through those little factors for you. So there's 4 main factors I want you to consider when you're thinking about writing UI tests or writing tests in general, but especially UI tests. So the first factor to consider is speed. Now, when your code is checked in, the team would like fast feedback to let them know if that check-in is good or not. So waiting for hours for test to finish is not ideal. No one wants to do this, right? You want to know right away if I check something in, it's good or not. So how do you get your test to run faster? There's a couple of ways that I want to share with you. Firstly, let me just say, while this webinar is about UI tests, this is not where the bulk of your testing efforts should go. People just struggle a lot with UI tests, which is why we chose to focus on that. But the reason I say this is not where the bulk of your tests should go is because UI tests are the slowest of your tests, right? So the very first thing you should do is ask yourself, what's the lowest level that I can write this test at and still gain the confidence that my application is okay? So unit tests are the fastest to execute, followed by service level or business layer type tests, and then your UI tests. Now, of course, I'm not saying to avoid UI tests. No one tweet and say, Angie said, don't do UI tests. I did not say that. UI tests, they are indeed necessary because you need to make sure that your application is presented in a way that you want your users to interact with it, right? So once you do have a good number of UI tests, you're cranking them out, you all have a system that's working well, what you're going to see is your build time is going to begin to increase, which is something you definitely need to keep an eye out for. So to speed up this whole process, another approach is to run the test in parallel. And I recommend that your team decide on a maximum amount of time that the build is allowed to take. Set this as a guideline, right? And then when you're developing your tests, ensure that they are written to execute below that threshold. And when I say that, I don't mean like, okay, the build can take no more than 5 minutes, which means every test needs to fall well beyond 5 minutes in order for this to work well. All right. Next, your tests have to be reliable if they're going to run as part of CI/CD. The state of the build is dependent upon the state of the test. So you have to avoid writing flaky tests. And what are flaky tests, you might ask? Okay, so flaky tests are ones that sometimes pass and then they sometimes fail, even when run against the same code base, right? So flaky tests, they are a detriment to your CI. False negatives, they require engineers to investigate the failures to ensure it's not their code check-in that's at fault. False positives, they're just as bad, if not worse, because they're basically lying to you. They're lying to the entire team and saying that the integration is okay when in actuality it's not. So if these flaky tests are causing problems on a regular basis, the team begins to lose trust in them altogether, right? And I'm sure many of you have been on teams where the tests are always breaking, there's blocking deployments, and so what do? You either ignore them to the point they're not gating your deployment anymore. You're running them, they're red, and you just don't even care, or you disable the test altogether. And neither one of them is a good place to be in, right? So how do you avoid this? How do you avoid writing these flaky tests? All right, I have a couple of suggestions for you. One, make sure that you make your application testable as developers, right? If I have any testers on or test automators, you need to work with your developers also to help them understand how to make the app testable. And some ways to do this, add unique identifiers on your web elements, right? So when you're writing your UI test, the script needs to interact with the elements that are on that web page. And to do so, it needs to be able to locate those elements. So having unique IDs is really important. Otherwise, you start crafting like CSS selectors or XPath selectors, and that's when things get a little wonky, right? Also, developers, create code scenes so that your test can bypass the UI for stuff like setup and cleanup, right? So this can be things like internal APIs or stored procedures. These things will also help with the speed of your test. So it helps you to bypass the UI for some sorts of things like getting your application in the state that you want it to be in or cleaning up after the test is done. Another way to avoid the flaky test is to manage the data that you use for the test. That's really important because changes with the test data, this is a common cause for a failed test. My preferred way of doing this is to create whatever data I need at the time of the test and try my best to minimally rely on the data that's supposed to already be there, right? And my last recommendation for reliability is to be mindful of the delays in your application. So our test scripts, they run a lot faster than we interact or our customers interact with our application. So that means if I click a button and let's say there's some asynchronous action occurring in the background, my script needs to wait for that action to complete before attempting to interact with the app in its expected state, right? Because the script is moving so fast, it might try to interact with the application too soon. So some of the JavaScript-based testing frameworks, they'll account for a lot of this. But if you're using something different or if there are simply cases where you need to control the timing, be sure to wait conditionally as opposed to hard coding a wait time. So for the sake of speed and reliability, you want to wait just enough time, right? Just the right amount of time before proceeding. And the way that you can determine what's the right amount of time is to wait for a specific condition to be met. Okay? All right. The next factor to consider is the number of tests you're automating. So there's a common misconception that You should automate all the tests that you can think about, right? If it's a test that comes to your mind, automate it so that we never have to run this again by hand. Well, this is a good idea in theory, but in practice, it's pretty much an awful idea, okay? This causes a couple of problems. With too many tests, it leads to longer execution times. And we already talked about this. We already said that this is a no-no. Also, you get these low value tests that you have put in charge of protecting your integrations or blocking those integrations, right? So if it's a low value test, you don't even care. I mean, if it fails, that's information, but it's not like you really wanted the build to stop, then it doesn't belong in your CI/CD pipeline. Also, the more tests you have, the more increased maintenance efforts you have. So what you should do is instead evaluate your scenarios. Determine which one of these are the best candidates for automation based on risk and value. So here are some questions that I like to ask of any test that I'm considering automating and putting in my pipeline. Okay. Which test would I want to stop an integration or a deployment? If I don't want this test to stop a deployment, it doesn't get automated, or maybe it's automated, but it's run like once a day on some other cycle, not on my CI/CD. Another question, which tests exercise critical core functionality? Those are the ones you want in there. Which tests cover areas of my application that have a history of failing? You know those areas in your app. This one is always breaking, it's fragile. You don't want to go in the code. You're, nervous anytime you have to touch that code. You want a lot of tests around that area. Or I'm not going to say a lot, but you want some tests around that area. And then another question is which tests provide, and listen to this one carefully because it's important, which tests provide information that is not already covered by other tests in the pipeline? So this is one that a lot of people miss. They look at a certain area, they code up lots of variations of like the same type of test. Here's the thing with that, and I'm sure many of you have been there, the developers have. If you check in a feature or a new thing or some type of modification. Let's say that thing is like 3 lines of code, nothing big or major. You check it in, you commit it, and there are 24 tests that fail as a result of that. You start panicking. Like, what? I only, changed 3 lines of code. What happened here? And you have to investigate every single one of those tests to figure out like how much did you break here. And after you've investigated 24 tests, you realize they all have failed with the exact same error. Did you really need 24 tests to tell you that, or would one test have sufficed, right? So it becomes noise. So I'm very careful about looking at what information I already have, because that's what your tests are running in CI for, to give you information about your application. What information do I already have covered? And if this test is not going to give me anything new, there's no need to add it. All right. Also, don't be afraid of deleting tests. It took me a long time to get to the point where deleting code felt good to me. Now I love to delete code, right? As your application evolves and you find that a test is no longer of high priority or of high value, go ahead and get rid of it. Get rid of it, right? It's one less thing to maintain. Which brings me to the last factor to consider, maintenance. So test code is code. Say that with me. I want you to repeat that at your desk. Test code is code, period, right? So you need to write it with the same rules, the same guidelines, the same care that you would any production code. And I see this a lot. I see really good developers, their production code is beautiful. I look at their test code and it is thrown together. It's awful. The same care was not put into it. Well, Angie, why do I need to be so rigorous with my test code? Well, your test code is the code that is basically monitoring monitoring your production code. Meaning, if your test code is sloppy, it's wrong, it's giving you false values and things like this, then your application code is not protected. So you need to take care of that. The other thing is you have to keep in mind that your test code is written against a moving target, which is your application. So your app is constantly changing. Features are being added, modified, sometimes even removed. So you have to factor in the time to consistently monitor your CI test results. Triage the failures. Don't ignore the red, right? Listen to what the tests are trying to tell you. Sometimes you'll look out and it's just the test that needs to be updated to match the intended new behavior of the application, but other times it's not, right? If you avoid this maintenance step, it's going to lead you to those untrustworthy bills. All right. Okay. So now you have some guidelines. Let's go ahead and write a few tests. But first, let me show you the application that we're going to be testing against today. All right. So this is a little chat application. It's fairly simple. You just put in a name, a username, and click to start chatting. And then you're inside of this little chat box. And so I can type little things like, hey, y'all, and boom, that's there, right? So that's the entire application. I'm going to go ahead and write a few tests for this, okay? Let's go to Jessica and I have this live share going. Thank you, Jessica, for introducing me to this. So this is pretty cool. So I'm going to write some tests here in this live share against that checkbox application. So I already have like a lot of the framework and stuff so that I could just focus on writing the test. So the very first test that I want to write is just a new session. We're not doing anything. I just want to make sure that I can enter a username and start a new session and that looks good, right? Okay, so I'm going to do this test annotation and I'm going to make a method that we're going to call new session. And inside of new session, I'm going to go ahead and launch the application. So that variable is already defined in this class that we are inheriting from this base test. So I have like all the config stuff in there. So we're going to say, go ahead and launch the application. And everything that we're doing today, like I love Java, so I'm doing it in Java. But it doesn't matter. This can be done in JavaScript or whatever is your favorite language to use. Okay. So after we've launched the application, I want to say, go ahead and enter your username. So this is also an object that I'm inheriting, this home page. And I'm going to say, enter username. And then in here, I'm going to just say my name, Angie. All right. So I've entered the username. Now I need to click the button. So I'm going to say homepage.click start chatting. And this returns the new page that I'm on, which is that one where we actually put messages. So you see I have this chat page already defined. I'm going to go ahead and just give it a value here. All right. And then finally, I need to do my verification. Now, I'm going to use visual testing in these tests so that I don't have to write a bunch of assertions. So I'm just going to say this validate window, which I'm also inheriting from base test, but this is using Applitools to do like visual testing, which will just take a picture of the entire screen and make sure everything looks okay. So I like to use that for my UI test. All right, so that's our first test, written, done. Great, let's go on to the next test. The next test I want to do is, okay, now I'm here, I want to enter a message, right? Let's make sure I can enter a message. So I'm going to do the test annotation again, and we'll call this one enter a message. And this time I'm going to say chat page.send message. And let's just say hello world. And then I'm going to validate my window again. Now, here's the thing. This test is starting from the place of entering a message because it's assuming like, okay, this stuff has already run, so I can just start here. The problem with that Remember I said when you want to run your UI tests and you start getting a lot of them, at some point you're going to say, I want to run these tests in parallel. In order to run your tests in parallel, all of the tests have to be independent. They cannot rely on each other at all. I also talked about like test data and setting up stuff and how each test should work independently. So if this test didn't run at all or it failed or anything, that has nothing to do with this test. It's not its business at all, which means I'm not in the right state I need to be in to start sending this message, right? So what I'm looking at here is that every test that I write pretty much is going to have to start this session before it can do anything. So I'm going to move this code outside of this test and make like a prereq or a setup type of method. So I'm going to add this annotation called before, and I'm using JUnit here in case anybody was wondering. Use whatever testing thing you want. I'm not here to promote anything. So we're just going to say before every single test. So before, or let me say before each test, meaning it's going to run not just one time, but before each test, we're going to say, go ahead and start the session. And I'm just going to move the launching and the username and the start the button. I'm going to move that to this method. That way, we don't have to think about that every time, and we know this will run. You can just think of this as a prefix to each of these tests, right? All right, great. So now these two tests, who cares? They're not relying on one another at all. All right, and then let's do a more interesting test here. So we're going to say, and this is the last test I'm going to write, public void, and let's do a multi-person chat. So this one will have both me and Jessica in it, right? Okay, so if I look at my start session, all right, I launch it, I enter my username. So Angie's entering the chat at that point. Great. So let's do Angie sends a message. And so we'll say chat page dot send message, and I'll do my hello world again. All right. And then let's say Jessica now wants to come and chat with me. So she opens the app and she's going to send a message. So I'm going to use this utility class I already have in here. And this one will open a new tab. All right. So I'm just going to give it that same app URL. So Jessica's going to open an entirely new tab. This is her chat window. So you can pretend like Jessica and I are not in the same place right now. So she has hers on her system. I have mine on my system. Is what I'm going for here. And then once she has that open, she can say, I'm going to say homepage dot enter the username, right? Because now this is a new user. So we'll say Jessica. And then let's go ahead and say click start chatting again. Homepage dot click start chatting. And I'll go ahead and do that. All right. So now she's in. We're both in. And let's just have her to send a message, Jessica. So Jessica is going to say, goodbye, world. All right. And that ends the chat. Okay. So after Jessica types her message on her end, I'm going to go ahead and switch back to my tab, the Angie tab. I just need to give it the index. So first tab, go there, and then let's do our validation to make sure both of the things are there. All right, beautiful. Okay, so those are 3 tests. Trying to keep in mind the rules that we've discussed here. Now, what we're going to do, I'm going to hand this over to Jessica, and Jessica is going to walk us through how do I then take these UI tests and get them ready for CI, because there's some things you need to do in the code to get them prepared for CI? And then how do I then integrate them into various pipelines? Jessica, you ready?
Yep, let me just unmute myself. So I've been made a presenter. I am now sharing my full screen. Hopefully everyone can see that. So for right now, I'm going to make this full screen so we can see Visual Studio Code, and we can zoom in just a little here. So Angie, can you highlight the test that you just created? I want people to see the way live share and what I was watching was working. Let's see, where'd you go? Oh, here you go. So this was the test that you just created. Can you highlight more of a section?
Yes.
Perfect. So notice that when Angie does something, I'm seeing on my screen her name pop up. The way that we're doing this is we're not screen sharing. She's not logging into my computer. You just watched her edit the code from her system, and she's accessing code that's actually hosted on mine. And this is easier for us because this way we're able to collaborate. In fact, when Angie was teaching me about visual testing, we used this several times so that we could go back and forth. And as a result, when I get to the point of checking in these tests and checking in our changes, it now makes it a lot easier. You can check out live share yourself by going to the extension marketplace, searching for live share, and it's a real live collaborative environment. It's paired programming as opposed to remote screen share. So it's great when you're, again, collaborating from different areas with developers. So thanks, Angie, for writing the tests. This looks great. I'm going to go ahead and save them. Now, the first thing I want to do is I want to make sure that these tests work locally. And I want to test it in a way that you, Angie, as a developer, or anyone else who's a developer on the call would be used to editing this. However, the way that you would run the test as a developer and from a local environment differs pretty dramatically from the way that you would run it in CI/CD, particularly because when you're running it locally, if you're using something like IntelliJ or even command line, if I just do Maven clean test, by default, when I call Chrome driver, I'm going to have my browser window pop up. It's going to tell me it's being controlled by automated software, and I'm having a graphic user interface experience. But in CI/CD systems, this is often run unattended, and this is often run from the command line, which means I also need to consider something that's called headless. So let's take a look at our base test file. We came up because there's, in my opinion, 3 different types of environments that would be standard to run these visual tests. So we created a class called getEnvironment. One option when you set an environment variable called runWhere is local. That's going to be the browser window that pops up and has the automated test and has the user interface. Your second option is going to be what's more of a traditional pipeline. That's a dedicated build server, whether it's hosted or something that you own that's private. That's a server that is running these commands from command line. You'll notice that we are still using Chrome options, where we have Chrome options referenced above here, and we're calling that with our Chrome driver. However, in pipeline, we're adding additional arguments. We're adding headless. We're adding no sandbox. This is if you're running it on Linux. If I were running it on Windows, I would also do -- disable GUI. And that should be a dash. So we'll do -GUI. So there's just a few things you kind of want to consider in that scenario. We're going to be running these on Linux servers. I have the application you've already seen is deployed out on a Kubernetes cluster. So the first thing I'm going to want to do is test this out locally, make sure that Angie's tests work. I'm going to export my environment variable to local. I've already exported things like my Applitools API key, which is a standard requirement, and I've also exported my URL, which you can see here are set environment variables that are required. We need to set a set start page. We also need a batch ID. I've already set those. By default, these will be captured in CI/CD systems, but when we test this locally, we'll account for that. So now that we've exported our local, I'm just going to run my normal Maven test. So all of our visual tests are in the visual test folder. I'm going to make sure I specify my POM file, and I'm going to say Maven F clean test. Now, because I specified local, the expectation here is that Google Chrome is going to pop up, tell me that it's being controlled by automated testing software. And I wonder if I have it minimized here. Let's go back. That's still There we go. So this is now popped up and we can see Chrome is being controlled by automated test software. And it's going to run Angie's 3 tests. I'd be able to go see that over in my Applitools account. So that tells me from the local experience that works. Now I'm going to want to do a third check, or second check, I should say, of testing that the pipeline would work. I want to make sure that I want to test in a headless environment that I still don't get any failures. So we'll let this finish. This build succeeded. We'll make this just a little bit larger. And now I'm just going to export my environment variable, only this time I'm going to change it to pipeline. I'm going to rerun my Maven tests. And now the expectation is that these same tests are going to run, but I'm not going to have that window pop up. Okay, and again, that's going to be important because when we're running things on things like Azure DevOps, GitHub Actions, Travis CI, really any kind of CI/CD system that is traditional, and I mean traditional in the sense that it's not container-based, you're going to want to be able to interact with your Chrome instance, which I have, by the way, there's blog posts that are going live during this webinar to walk you through the technical details and how to set your servers up for this. But we're going to want to make sure we can interact with that without the expectation of the GUI launching and possibly giving us an error. So once this passes and says success, we can also test our containers locally. And I'm going to show you how to do that. Rather than using Chrome driver, which would be the standard way we're interacting with everything that Angie set up, and the fact that I have local access to a browser for Chrome on my system, instead we're going to use something called Remote Web Driver. And I'm going to use Selenium Hub, which allows me to spin up whatever kind of browser I want. In fact, to do that, I'm using a Docker Compose file. Now, the reason why I wanted to also highlight this possibility of CI/CD is we are now in a cloud native era where we are now seeing more and more cloud native style pipelines. You can do Jenkins-based pipelines. There's Jenkins X for Kubernetes native. You can do CodeFresh, which I'm going to show you in today's demo. It's a CI/CD specific pipeline dedicated to Kubernetes and microservices. So every task runs in a container. I want to test that that environment works with Angie's tests. And to do that locally, I'm going to spin up Selenium Hub. I'm going to attach Chrome node. You can see that it depends on my Selenium Hub service. I make sure I give it a host. And then I'm going to do the same thing with Firefox. So if I export my environment variable one more time and I type in container, I'll clear my screen. And this time I want to make sure that I also say, let's spin up all of these services. Now, when I'm running this locally, I don't have a nice nifty little service name that I would have in a CI/CD system. And what I mean by service name is that's this right here. So I can't query it by a local DNS. But what I can do is I can make sure that it's listening on home, because if you noticed, and I mean home 127.0.0.1, I am port forwarding access to my hub. So let's test this real quick. I can run telnet, and I can see that I can now connect to my Selenium Hub. So let's clear. I'm going to make one change right here where we're going to change Selenium Hub, and we'll change to 127.0.0.1. And I'm going to save that. Now I should be able to run my tests still locally, only this time it's running against the Docker Compose set of services that we just spun up. And again, all of this is important that we test out locally because we're going to be redoing this in CI/CD systems. All CI/CD is a collection of tasks that you would be doing manually. And we're going to automate those tasks in a definition file. Typically that's YAML, unless you really, really like pain and you choose to write Groovy in Jenkins. No judgment. I have an extensive Jenkins pipeline as well, but I won't be showing that today. I want this to finish. And while this finishes, let me snap this screen over to the right here. And I want to show you Azure DevOps because I have a pipeline that's already in existence. This is going to be the pipeline we're going to start with working. And I have 3 different stages. I have a build stage of this existing application. I have a deploy to development environment stage, and I have a promote to production stage. And if we take a look at our build stage here, we'll notice that it's actually doing quite a few things. This little ChattyBot application is running on a very large cluster in Azure. It's running in Kubernetes. It's deployed with Helm. There's a lot of things that are going on. In fact, I'm using JFrog to package up all of my dependencies for Maven. I'm using JFrog X-Ray to scan those dependencies and make sure that I don't get any kind of security errors. I'm creating a Helm chart and packaging that up. I'm sending off Slack notifications. This is an extensive pipeline. And when Angie and I first met, I was wondering how hard it would be to integrate her tests into an existing environment. Well, as it turns out, if we take a look at our existing dev environment, all I'm doing is making sure that I grab that Helm chart. I make sure that I have my pipeline artifacts. I make sure Helm is installed on my build server, and then I deploy. And because Angie taught us how easily we can go ahead and query that URL and how easily we can go and run our tests and whatever we're doing, all I have to do is make sure that I put the same tests that I just did manually. I make sure that I do that in an order that makes sense from CI/CD. So let's take a look at it. Let's go back over to Visual Studio Code here. I'll collapse the side browser. I'll close my Docker Compose. You can see the container finished. Clear the screen here. I'm going to export this back over to Pipeline just because we're going to start with Azure DevOps and that's more traditional. And I'm going to open my Azure Pipelines page here. So you can see this was the last deployment step. In fact, if we scroll all the way up, the stage we're working on is deploy to dev. So this is that development step. We just saw one of the last tasks it does is it deploys to my development environment. I'm going to want to run Angie's visual tests against dev, against test, against QA, against Canary. I want to run it against every single environment before it hits prod. Because as Angie pointed out, these tests, these integration tests, these UI and visual tests are crucial to make sure that we're not deploying something wonky into production. So we're going to add it in an order that makes sense. We'll drop down over here, over into our task. YAML is sometimes hard to make sure we're lined up here. And the first thing we're going to do is we're going to add a bash task. And I love writing, believe it or not, in YAML because I can just simply add in commands that I would normally use. Now, one of the first things I want to do is I want to comment this because I have quite a few bash tasks in here, including my Slack triggers. I want to make sure I know which task or what this is actually doing. The next thing I want to do is I want to run set an environment variable that's going to set a counter. I need to make sure that after this step gets deployed, that our website is truly up and running. So I need to do an HTTP check, right? I want to curl, I want to make sure I get an HTTP 200 response, that everything is working and I don't get some sort of an error. So I start with a counter at 0. I'm going to max this out though. I don't want this test to run indefinitely. If for some reason the deployment does not respond, then I'm going to need to make sure that I kill it after a certain amount of time, right? I want to be mindful of how long we're letting our builds run. So I'm going to set max attempts to be equal to 5. We'll limit it to 5. We'll set a 20-second delay. We'll let this run for about 100 seconds. The next thing I'll do is I'm going to start setting an until loop. Until this gets a response, do this action. So we'll start saying until we curl. I'll set the output. I'll suppress it. I'll make sure everything's silent. And then I make sure to tell me if it fails. Here's the host name. Now we'll talk about the host name environment variable because I actually define that for my entire development stage. This allows my pipeline to be dynamic. So if I ever change my host name, I can go back and easily change it in one place as opposed to multiple. So if I highlight host name right here, you'll notice I'm also using host name right here in an environment variable. And I'm able to consume it in multiple steps because it's defined at the very beginning of my stage underneath variables. And so rather than changing it several different places and potentially getting faulty errors or false failures, I just change it in one place. So once I have that, we'll go ahead and edit the indenting right here. So I want to make sure that, let's see, this looks proper. And then we'll tab down just a little bit more. The next thing I want, since I've suppressed all the output, is I want to have some sort of an output. So I'll just make sure that every 20 seconds, I'm getting at least a period that it's moving along, it's doing something. And then I'll set my attempt counter to be equal to attempt counter, which is, again, the environment variable we first set up here. But instead, I'm going to make sure I increase it by 1 every 20 seconds. Then I'll go ahead and add a sleep. That sets our 20 seconds. I'll back up and hit done. Boom. That's going to be our check. But again, since I'm a fan of labels and I want to make sure that I know what this is, I'm also going to set a display name, and I want that to be equal to HTTP check. So just like that, we have our query to make sure that our application is up and running. The next thing we're going to have to do is make sure we have our appropriate environment variables. Those are the environment variables I told you we were going to capture here. And then we're going to want to run our Maven commands. Now, this is where it gets a little bit more challenging, especially if you're writing these tests from scratch, because a lot of times people don't know the syntax. So I'm going to drop down. We'll go back over to where we're in line with this dash, and I'm going to move this over to the side. And actually, I'll make it where it's behind the window. Instead, we'll make this bigger. We'll go back over to our build within Azure DevOps. And right over here, there's a stack set of dots. I'm going to hit Edit Pipeline. And the cool thing within Azure DevOps right now is that you can actually edit your YAML completely inline in your browser. So we'll scroll down to right after that deployment step right here, our Helm deploy, and we'll tab over to that dash, hit over, finish, just making sure that everything kind of looks clean, white space. And I have an Applitools build task right here. I was able to get this by installing an extension. There'll be links at the end that show you how to do this, but watch how easy it is to write this line of YAML. It's one click and I'm done. That's going to take care of all of my environment variables. So now I'm ready to start with my Maven task. But rather than doing another bash command, Maven, -f, all of this, I actually want to get my test results, my JUnit results, published directly to my build. And I can do that using the built-in Maven task that's available. And so if I'm unsure of how that syntax goes, I'm given help right here from the task plugin. So I'm going to say where the visual test POM file is, which we know it's located in visual test/pom.xml. And then the goal is going to be test, right? The next thing is we want to make sure we give it an option. I want a clean test. I do want to publish my JUnit results. It's fine if the test result files go to this path format on my build server, and I don't have to worry about code coverage or SonarQube or anything because that's outside of the scope of this webinar. But again, making sure that I'm in line with this dash, all I have to do is hit add. And just like that, all of my YAML is now written for me for that task. I still need to set some environment variables, but I'm going to copy this YAML. We'll go back over to our Visual Studio Code and make this nice and big, and I'll paste that right in. Again, being sure, playing with YAML, making sure that dash is there. So now I want to make sure that I tell this task specifically to use the environment variables we know that we need. First, I need the Applitools API key, and that's going to be equal to an exported secret environment variable I have defined, API key, making sure I spell that correctly. And I've defined, if we take a look at Chrome again, I've defined that right in variables. Here's my API key. In fact, if I open it up, I can't see it because I've told it to keep that value secret. So I'm going to be able to utilize a $ and parentheses to consume that environment variable for this task. Next, I need to make sure that I set that run where environment variable we played with locally, right? So I'm going to set it to pipeline. Finally, I'm going to set my test start page, and I'm going to set that to check this out. We'll set this, and we're going to use the same host name again. So now in 3 different steps, in Maven, in my HTTP check, and in my deployment step, I have host name being reused, which now makes it dynamic. In the event that I were to hard code this, I'd have to change it and potentially screw it up. So just like that, we now have our Azure DevOps pipeline written, right? We are going to make sure that our application is up and running with our HTTP check. We're going to make sure that we are consuming the Applitools specific environment variables, and then we're going to go ahead and run our Maven clean test. So I'm just going to double check that, again, didn't have any major spelling errors. This is always the fun stuff with live code. Accidentally fat finger something. Visual tests look good. Applitools API key. If you don't export this, you will get an error and a failure. But now that that looks good, let's go ahead and check in our changes. By the way, when you are in a live share session and somebody joins, it's actually going to automatically add this co-authored text. So that way both parties get credit on the commit ID. So I'm going to say live coding webinar, yay. And actually, before I change this, there's one more thing. Let's go ahead and actually make a change to our application, and we can watch Applitools detect differences. So right now, if you saw when Angie was doing the demo, you notice that it said, hello, DevOps Days Madrid. We are obviously not in Madrid, especially with the coronavirus going on. So instead, let's say, hello, awesome webinar attendees. Great. And so now that's going to be a different change. We'll save that. I'll go back over and check that in. So we'll check in our pipeline. We're changing that. We're changing our awesome webinar. We have our chatty bot multi-person test that Angie added in. We can see that looks good. I'll go ahead and say yes. And then I don't think we did make a change here, but I'm going to revert that. Remember, we want to make sure we keep Selenium Hub for CI/CD. So I'll just discard that simple change. Now we have everything staged. I'll hit commit and I'll hit push. Now, once I have, because I'm adding this to this existing pipeline, I already have Azure DevOps set up and ready to run this. So we can go back over here to Azure DevOps. I'll leave. And you can see when we refresh, here's our live coding webinar running. And so when this finishes, this is going to be able to show us, potentially this should fail on our deployment dev step. You'll see the step pop up when it starts running the tasks, but it should fail on our Maven test. I expect that to, because it's going to detect differences and we now have a different baseline. If I go over to a previous build, I can show you. Let's go into Azure, adding our visual test. I tested this right before our webinar. You can see by publishing our JUnit results, 100 tests pass. I can drill down into that, which takes me over into my test tab. And right from within Azure DevOps, I can see whether or not it passed or it failed. I can also click on Applitools. And as long as I'm signed into my Applitools account, my dashboard should actually pop up here and show me what passed or failed. So I can see that. I can click on one of the messages, drill down into this, and actually take a look at both the baseline image and the checkpoint image. And I can choose to update that. Angie can definitely comment a little bit more, but I can choose to update on if any area of text was potentially changed or different from the baseline to whatever change we made. And I have access to all of this information right from within my Azure DevOps build. We'll go back here and make sure that this is still monitoring. While this is running, a common question, you can see here's my Slack notifications. A common question I get asked is, this is cool. Thanks for showing it in Azure DevOps. I'm not using Azure DevOps. How do I do it in something else? I'm so glad you asked. Regardless of what platform you're using, TeamCity, Travis CI, Octopus Deploy, Jenkins, CodeShep, it doesn't matter. You're still going to be setting up tasks that make sense. You're going to need to run an HTTP check to make sure your dev test QA site is up and running. You're going to need to make sure you have access to your environment variables. And then finally, you're going to need to make sure that you run your Maven command line test. So let's take a look at GitHub Actions. And we'll make this bigger. I have a GitHub Actions workflow that's existing. I ran this without visual tests. I have an additional stage in GitHub Actions that even deploys out my infrastructure. This is massive. I didn't want to have to rewrite it. There's almost 500 lines of CI/CD code. It sets up a ginormous AKS cluster with a ton of different things. But if you take a look at the dev deployment, it's doing the same set of tasks that Azure DevOps was doing. And if I flip over to a build where I added visual tests, I didn't have to change anything. I didn't have to change my infrastructure, my build images of using JFrog, Artifactory, X-Ray. When I get into dev, I still have an HTTP check. We'll make sure we minimize that. I have an Applitools build task, which the only difference is I'm exporting these environment variables in Bash, because as of right now, there isn't an extension to do that for me, but that's fine, a few simple lines of Bash. And then I have my visual testing. There's one additional thing I do, which is really kind of preference. It's just to make sure that you're extra careful that I am explicitly setting Java version 13 for this test, because that's what the test requires. And then I have my visual test right here where I can see again at the bottom, scrolling down, I have a build success. Now, the one thing we showed also local, remember, we talked about containers. Here's where containers can get a little bit challenging when you're doing CI/CD. You need to have a way to reliably spin up your Docker Compose and your services. So I really like CodeFresh because it's Kubernetes native. So if we take a look at a giant CodeFresh pipeline that I have, and every single one of these steps runs in a container, which means lower maintenance. I'm not having to log into a giant build server and make sure I have all these things set up, all of my Java dependencies, Maven, tools, etc. Instead, I have access to just what I need because I'm running just Docker for my Docker image. I'm running just JFrog for my Artifactory image. I'm running Helm lint or whatever I need, I'm just specifying in the container. This is an example of my pipeline, again, before I added in the 3 checks we talked about. And here's an example of it when you add it in. You still have an HTTP check, you still have a build task, and you still have a visual test. The only difference is these visual tests are running directly against services that we're spinning up right alongside it. And let me show you that really quick. If we go over here, again, just like GitHub Actions, Azure DevOps, Travis CI, CodeFresh works in YAML. And so here is my visual testing step. And I'm explicitly saying to use services called Selenium Hub. I define those services at the very top right here with services. Let me scroll down to line 40. And you'll notice I give it a service name called Selenium Hub. That's me attaching it. But if you take a look at the syntax, it's almost identical to Docker Compose. So it makes it very native and easy when you're dealing with container-based or Docker-based pipelines. Now let's flip back over. I've seen some Slack notifications come in that it looks like we got a failure. And that's exactly what we expected, right? So I can see it failed, and it looks like it failed to validate the window. Perfect. Let's flip back over to our Applitools tab and take a look at why it failed. Let's let this load. And everything is unresolved because now it detected the change that we made. It went from Hello DevOps Days Madrid to Hello Awesome Webinar Attendees. And now I can sit here and say, yes, this is good. This was a necessary change, or no, this was completely unexpected. We accidentally made the buy now button white and our background is white. And now we have lost $100,000 in sales for the day. So with that, I'm going to go ahead and turn it back over to Angie and let her go ahead and kind of wrap up.
Thank you. I was like cracking jokes and everything. Y'all missed it. All right. I don't remember what I said. So thank you, Jessica. That was amazing. And Jessica has provided us with not 1, not 2, but 3 blog posts further detailing everything that we did today. So you can access them by going to this link at the bottom of the slide here, and we'll also include this in an email to you with the recording of this video, so you'll have all of this content in your inboxes within a day or so. Okay, Dee, do we have time for questions, or are there any questions for us?
Yeah, there were a few, so we can take them until we reach the top of the hour.
Okay.
So first of all, there was a question while Jessica was wrapping up her demo. What do you think about creating a web service to run any kind of automated test from the pipeline?
Can you elaborate on what kind of web service you would be creating?
That was the question that I have.
Okay.
If they get follow-up,
let me try to answer it as best I can without knowing what kind of web service. If you're thinking of creating a function or a second system or tier, remember that the more you add abstraction, the more layers you add to your cake. Or if you've heard me also do this demo where I talk about waffles, because I believe containers are waffles. There's a whole other blog post and thing you can watch about that. However, the more complication you add, the more you're responsible for. And so one of the questions I always ask people is ask yourself one very important question. Does this add additional value, or does this add unnecessary complexity? It might sound super cool. In fact, when I was first writing this entire pipeline, even to get the Slack triggers and Slack notifications and all of that, I was thinking big. I was thinking, I'm going to have an Azure function. I'm going to have this query over into serverless. I'm going to have it post over here. And I finally sat down and thought about it and realized why. There's no added value by me adding so many more layers to this cake. Instead, if you want to know what that Slack trigger is, it's a curl command. I'm just posting using a webhook over to a Slack channel. So the simpler you can take it, the easier your life is going to be. Angie hit the nail on the head earlier, even for developers. When you start deleting code, when you can get to that point that you feel good about it, it's such a relief because now you're managing less code. She talked about how you don't need 12 tests to tell you the same thing. Do you need 12 different layers of abstraction when one will do the same thing?
So next question was, unless Angie, you want to add something?
No.
Oh, okay. So next question. Have you come across a case where the tests pass locally but fail when they run in a remote web driver?
Yes, usually that is related to where you're telling the remote web driver to go. So I have another demo, which I haven't written a blog post on that, but obviously we focus very heavily on Java. I have one where you can use remote web driver and Python, and there might be some differences depending on, again, how you're spinning up that remote instance. So in the demo we did today using remote web driver, we used Selenium Hub to be able to access that. You have to remember when you're using Docker Compose, and I talk about this in my third blog post, which focuses specifically on container-based pipelines. Let's say that you weren't doing this in something that's specific for microservices. Let's say you're doing it in Jenkins, which is fine, you can. But there's now going to be additional responsibility that's put on you as the infrastructure architect to make sure that your remote web driver code container can actually communicate with the Selenium Hub Docker Compose. Remember the way that Docker networks work. You're going to have to make sure that you link your containers together and can be attached. So if you can communicate and attach to your 127.0.0.1 locally, and you can't in a remote scenario, you probably have a networking issue.
Also, I'm going to add to that. So that was great. And then another thing you can look out for is that waiting I told you about, right? So sometimes we'll see where it'll run locally, but on other systems, it's failing. And that sometimes has to do with like some type of timing issue. So make sure that you have waits in there where you need to, and make sure all of them are conditional, right? So if I'm running locally and I hard coded like a 3-second wait or 3 millisecond or whatever, and then I run it somewhere else and it takes 5, then of course it's going to fail over there. But if you wait for the condition, it doesn't matter which one of, if it's 3 or 5, it's going to wait as long as it needs to wait, no matter what environment it's running on.
Absolutely. And then to build on top of that is, remember, even the test is going to fail in probably virtually any environment, but especially in CI/CD. If I deploy to that dev test QA environment and something fails, maybe Kubernetes fails, maybe I don't have enough resources that it can use, that's where that HTTP check comes in. So I am waiting for the condition that the HTTP returns 200, but at the same time, I know in any environment, this application should be up in a max of 70 seconds. I'll give it a timeout of 100 to be generous, but I'm not going to sit there and wait for it to just magically spin up if I know it's going to fail. So that's also why you have checks and balances to account for in your pipeline.
So I think we have time for one last question, it's how would you run the test if the application requires authentication or even with MFA?
I will let Angie take that one.
So whatever testing library you're using allows, some of them will have functionality to be able to do some type of authentication, whether that be via the web itself, or if you want to bypass that, like I talked about with the code seams of, maybe doing an API call or something like that. You can manipulate cookies and stuff within your browser using these web tools as well. So there's definitely functionality in a lot of the tests tools. And if it's not in the test tool, then usually they'll still allow you to program in whatever language you're using, so you can still manipulate it that way. For example, I use Selenium in this live demo. Selenium has a way for me to manage cookies and stuff like that, so I can bypass a lot of the authentication. But even if it didn't, it still allows me to inject JavaScript if I needed to.
Great. So unfortunately, that's all the time that we have for today. Before I let Angie and Jessica say their goodbyes, I just want to thank everyone that joined us today for this live session. And of course, thank our expert speakers, Jessica Deen and Angie Jones. The recording will be sent to you by end of day Monday. And I do hope to see you all at our next event.
Thank you, everyone.
Thank you so much, everyone.